People who love ICP, the ICP juggalos, if you will, like that everything on ICP exists within the ICP network, and this is called blockchain singularity. Nothing is linked or cloud hosted like most other things are on blockchain. And yes, that includes every single NFT that's not inscribed on Bitcoin or Doge.
Designed to be a world computer and host things like social networks and enterprise systems on the blockchain itself. And to do that, it has to be unbounded. It has to be able to scale without limit, host any amount of data, any amount of computation, and do so very efficiently. I think one of the big surprises of the internet computer is that eventually, not only can blockchain act as a crypto cloud that replaces centralized tech, but that crypto cloud can actually be more efficient than centralized tech in the end. And of course, being green and reducing the emissions of technology worldwide is a key objective. The internet computer has very fast growing and vibrant community of developers building. We've seen just about every kind of Web3 service imaginable, and now we're increasingly seeing enterprises experimenting with building tamper-proof and unstoppable systems on the internet computer that run without the need for a firewall or security team. 2 years on from launch, we really are well and truly on the road to realizing this vision of a blockchain singularity where almost everything one day will be built on the blockchain, and the blockchain will play the role.
Everything exists on the Internet Computer Network Nervous System, or NNS, the foundational core of ICP. Basically, the NNS is a governance mechanism that oversees the protocol made up of neurons instead of nodes, which are the fundamental checkpoints for governance and staking. Neurons are created when users send ICP tokens to the NNS and put them in locked staking, which determines voting power, but more on that later. I mention this because staking rewards are sky high, so keep watching. The NNS is responsible for network operations, upgrades, and economic policy. It operates as a decentralized autonomous organization, or a DAO, allowing ICP token holders to participate in decision-making through staking and voting.
So on a high level, the internet computer is a distributed protocol run by multiple nodes. And the nodes are depicted on this slide as the green and blue dots. So these nodes can, for example, be physically located in different data centers, and they then talk to each other over the internet to achieve a consensus on what the state of the internet computer should be.
The next layer of ICP consensus is canisters.
This underlying communication and consensus protocol, the internet computer hosts so-called canisters, which are stateful programs that can also communicate with each other.
Now, canisters are the fundamental building blocks for creating decentralized applications, or dApps, and other services right on internet computer. Think of them as virtual computers running on the blockchain that can store data, execute code, and communicate with other canisters and external services. ICP introduces the concept of internet identity, a decentralized identity solution. This allows users to authenticate themselves across different applications and websites without relying on traditional login credentials. It's a fundamental building block for the emerging Web3 ecosystem, prioritizing user privacy and data ownership. And I'm going to walk you through the process of getting an internet identity in this very video. So make sure to stick around and make sure you check out the Bit Squad exclusive affiliate link for Femex. The link's in the description below. You get $8,800. You can join me on Femex Pulse. Make sure to check it out. Before we do the tutorial, let's get into staking though, because if you're willing to wait for lockups, ICP gives the highest APY rewards in the game. Staking ICP involves locking up tokens to support network operations and security. In return, stakers receive voting rights in the NNS and earn rewards in the form of additional ICP tokens. Staking process facilitated through specialized wallets and platforms. And it offers different lockups ranging from 6 months to 8 years. Longer lockups yield higher rewards, incentivizing long-term participation and commitment to the network. This website is everything you need to get started with ICP, and I'll click through the process of actually getting an internet identity and how to stake ICP. First, hit sign in with internet identity. Then click create internet identity if you haven't already done so. Create a passkey and scan the QR code on your phone, prove you're human, then copy and save your brand new internet identity. This isn't a seed phrase, but it can be stored wherever you keep sensitive crypto information. Drop that spot down below. I'm just kidding, don't do that. Click on ICP, then buy or send some ICP to your account. This is how you can lock up ICP to vote on proposals and get rewards. Higher lockups and actually participating in voting gets the highest rewards, so DYOR before investing in staking. You need high conviction to lock up for long periods. is for voting. If you don't want to do the work yourself, ICP has a follow system that puts everything on autopilot.
Some other neurons, which are called the followees, and the governance canister would know this. And whenever a majority of the followees would send the same vote, the governance canister would automatically also send this vote for the follow.
ICP wants to redefine the internet's architecture and put it all on chain. Still in the early stages, but the project has already demonstrated the potential for blockchain technology to disrupt traditional systems. ICP is flying under the radar right now, and I believe it's one to watch as Web3 quietly debuts into mainstream.
If you build your social network, social media, metaverse, game, DeFi, whatever it is, fully on chain, you can put it under the control of an internet community through a DAO. And that's what Web3 is all about, that you can enlist the community as part of a virtual team that will go out there and help promote the Web3 service and create content maybe in return for token incentives. Web3 is all about giving ownership to the end user. The ultimate destination of that is things like social networks that run under the full transparent control of community DAOs. And that's what's happening on the internet computer today. On-chain is incredibly important. I'll give you some examples. Let's look at DeFi. MiCA, which is the Markets and Crypto Assets Regulation in Europe, means that if you build a system like Uniswap out of Ethereum smart contracts, which are decentralized, but you then go and build a centralized user experience, for example on Amazon Web Services, because you build a large part of the system centralized, you'll be required to do KYC. One way to solve that is you can build the user experience on the internet computer, you can put it under the control of a DAO so that the user experience is completely decentralized. And then you basically go full stack decentralization. You've got a decentralized user experience, and it might help you with respect to regulations like MiCA. The history of the internet computer really dates back to the mid-1990s when I began working on distributed systems. By the dot-com era, I was also working with cryptography and trying to create what would have been one of the world's first cloud services. 2013, I got into Bitcoin, and by the end of the year, I decided I wanted to create a virtual currency for the games industry. I circulated a paper in October 2014 repurposing traditional Byzantine fault-tolerant consensus math. I got involved with the early Ethereum community, and I'd seen how blockchain could do much more than just cryptocurrency, and you could in fact use a blockchain to host code and data and computation. At some point I'd heard the phrase world computer. To me, world computer, it meant an extension of the internet that you could use to build almost any system and service using smart contracts. I renamed the project Definity, which is a shortening of decentralized infinity, and began working towards this new goal of creating a world computer. The Definity Foundation was created in October 2016, and then it ran a big public ICO in February 2017. That enabled us rapidly to expand the Definity R&D team. By the end of that year, we were running the biggest R&D operation in blockchain. The people we have at Definity are just the most incredible bunch of hardworking, visionary, talented people that you could ever imagine. And I'm grateful every single day that I come to work. When the internet computer mainnet finally launched, it was pretty wild. As an organization, we're primarily staffed by R&D folks, as is the nature of the project even now. Meanwhile, while all this wildness was going on, we had to contribute to the network to keep it up and running. The internet computers managed to run the last 2 years without any downtime. There's been so many improvements that have been added to the internet computer in the last 2 years. There are almost too many to mention. Just recently, something called chain key Bitcoin went live. Internet computer nodes actually talk to Bitcoin nodes. That enables smart contracts on the internet computer to directly process Bitcoin on the Bitcoin blockchain without need for bridges. The next step is to integrate with Ethereum, which will allow smart contracts on the internet computer to process any asset on the Ethereum blockchain and call into Ethereum smart contracts. And that's a big deal because internet computer smart contracts can serve user experiences by processing HTTP. And that's a very unique capability. By integrating the internet computer and Ethereum networks, we'll be giving that unique capability to Ethereum smart contracts too. So one of the very cool things about the internet computer, it's the world's first adaptive blockchain. And that means that it runs under the control of a decentralized governance system. And you can submit proposals to this governance system that change the structure of the network or run protocol upgrades, and they'll be executed completely automatically. This differs from traditional blockchains, which are upgraded through a process known as hard forking. Through this governance system, the internet computer has already been upgraded 145 times in the 2 years since mainnet has been running. The Internet computer's designed to be a world computer and host things like social networks and enterprise systems on the blockchain itself. And to do that, it has to be unbounded. It has to be able to scale without limit, host any amount of data, any amount of computation, and do so very efficiently. I think one of the big surprises of the Internet computer is that eventually, not only can blockchain act as a crypto cloud that replaces centralized tech, but that crypto cloud can actually be more efficient than centralized tech in the end. And of course, being green and reducing the emissions of technology worldwide is a key objective. The Internet computer has very fast growing and vibrant community of developers building. We've seen just about every kind of Web3 service imaginable, and now we're increasingly seeing enterprises experimenting with building tamper-proof and unstoppable systems on the Internet computer that run without the need for a firewall or security team. 2 years on from launch, we really are well and truly on the road to realizing this vision of a blockchain singularity, where almost everything one day will be built on the blockchain, and the blockchain will play the role of a world computer that's the everything stack that will eventually eat centralized technology.